In previous parts, I've talked about attributes critically determining optimal application of LMAX, described some limitations which restrict use of similar steels for cutting tools that require highest possible cutting performance, meaning very low edge angles, less than 10 degrees per side, very thin geometry behind the sharpened edge, less than 0.2 millimeters at 20 degrees total sharpening angle. This knife is made out of vanadis 4 extra and has been tested extensively for edge retention. It performed very well. It have cut longer than some other knives made out of more heavily or higher carbide steels. That's surprising. And it also demonstrated reasonable edge stability relative to its high wear resistance. So we can consider this heat treatment to be not far from optimal. It is definitely decent. And this steel is considered to be very tough. However, I observed some behavior. This knife, as you can see, has very wide sharpened bevels, because the last angle that we tested the knife on the head probe was 25 degrees. An interesting thing is that during the testing on the hand probe, at the 25 degrees, the knife, we can say, scored 450 cuts until it stopped cutting the printer paper. And at 425 cuts, some part of the edge rolled or bent, we can say, slightly. Apart from that, there was no microchipping at all. However, in daily use, while I use knife only very lightly with caution, because I'm aware of some carbide in these steels and low angle, the microchipping does occur. I don't know how and when. I just look at the knife after some time and I see after a week of use that there is microchipping. However, during the testing, after hundreds of cuts, there was not a single microchip. And it has been observed by 300 magnification with a microscope, so there definitely was not a microchipping. It shows that during the daily use at this angle, the steel doesn't have the toughness anymore to keep the very apex or very last parts of the edge attached with the rest of the knife. And as this steel is considered to be very tough, it seems to be on its limit at the moment. On the other side, this steel is AEB-L, and it's been heat treated to 62 to 63 HRC, whereof this one for vanadis 4 is 61, which is not a lot. You can take with a decent tempering vanadis to 63 plus. So this is about 1.5 Rockwell higher, and usually I use 20 degrees, sometimes 15 degrees sharpening angle, which is basically just a micro bevel, because I zero ground those, almost zero grind. When I have edge thickness of about 5 micron, then I put a micro bevel. I polish and then sharpen the knife. And with this, I never experienced any microchipping. I chipped it once, but I knew I'm doing something that I'm not supposed to do with the knife. However, the microchipping does not occur. The dulling of the knife happens just by the slow wear. So it shows that this material at its 62 plus, it's tougher than this particular vanadis 4 extra, and I will explain it on the micrograph, which you can see at the moment. On the left you have steel which is sold by name as AEB-L or Sandvik 13C26. On the right you have S30V, which is very similar steel as an LMAX. Vanadis 4, the knife I talked about, is somewhere in between those. It's actually closer when it comes to carbide volume to the left micrograph, because it has about 6% or maybe up to 10 of carbides, whereof the AEB-L has 3% or even less of total carbide volume. And by red lines I depicted or illustrated the apexes of the knife edges at different angles for 10, 20 and 30 degrees. And little islands you can see on the micrographs, those are the carbides. So here you can see the size difference in particular between these two steels, and you can see or you can easily visualize how much matrix or martensite surrounding the carbides will be in the very apex at your very sharpened edge. So the problem with high carbide steels is that the lower angle you use, the less matrix is surrounding the carbides, and because there is no real bond between the carbides and matrix, once it's not surrounded sufficiently by matrix, that part of material doesn't actually hold together by, it can be damaged by very light force. So you could only benefit from wear resistance of any alloy in the world only if your edge is still attached to the knife. So this is to demonstrate or to illustrate that there are geometries and designs and angles which cannot be used, or they are highly inoptimal if you combine them with high carbide steels, wear resistant steels. And this applies widely to all other bunch of steels like M390, 20CV, CTS204P, S30V, which is on the micrograph, XHP, or an LMAX. LMAX will be pretty similar than the S30V on the micrograph. It has very similar carbide volume, maybe it's even a little bit higher in carbide volume. So this is the reason why these steels are not as tough in very thin portions as the more simple steels with less carbides that are heat treated to very high strength.